Imagine for a moment the audacity of spilling water into the vastness of space. Picture it, a cascade of liquid, shimmering droplets, breaking free from the confines of a vessel and drifting into the void. In an instant, the laws of nature would spring into action, revealing the delicate dance between water and the cosmos. The first thing to note is the sheer thrill of rapid evaporation. In the vacuum of space, where pressure is a mere whisper, liquid water would not linger. It would boil, bubble, and vanish, transforming into vapor almost instantaneously. It's as if the universe itself is saying, not here, not now. But what if that water were frozen? Ice, with its crystalline structure, would not melt into a puddle, but rather sublimate, skipping the liquid phase entirely. It would transform directly into gas, a ghostly wisp of water vapor, floating away into the cold embrace of space. Yet, this vapor wouldn't last long. The frigid temperatures lurking in the shadows of Earth, plummeting to a bone-chilling 250 degrees of Fahrenheit, would seize the vapor, forcing it to condense. Ice crystals would form, delicate and ethereal, creating a fleeting cloud of frost that dances in the darkness. As these ice particles scatter, they become part of a transient spectacle, a shimmering veil against the black canvas of the universe. This cloud, though ephemeral, would capture the imagination of anyone fortunate enough to gaze skyward. Perhaps satellites would catch sight of this celestial phenomenon, a testament to the unexpected beauty of science in action. But let's not forget the Earth below. If this water were released from low Earth orbit, it would eventually interact with our atmosphere. Some of those ice crystals, drawn by gravity's gentle pull, would find their way back home, merging with the air we breathe. They would contribute to the thin layer of water vapor that exists high above us, a reminder of the intricate connections between space and our planet. Yet the spectacle doesn't end there. Solar radiation would join the fray, bathing the ice particles and water vapor in a warm embrace. Photons from the sun would collide with these tiny entities, exerting radiation pressure, pushing them further into the cosmos. It's a cosmic game of tag where the sun's rays become the playful hands that scatter the remnants of our spilled water, spreading them across the vast expanse. And what of the gravitational effects? Earth's gravity, ever the steadfast guardian, would not let these particles escape entirely. Some would be drawn back, pulled into the atmosphere, where they might re-enter as precipitation. Imagine a sprinkle of space water falling as rain, a minuscule contribution to the hydrological cycle, a poetic reminder of the interconnectedness of all things. Yet in this grand experiment, practical considerations loom large. If the water were released from a spacecraft, it could create a plume, a trail that might interfere with instruments or alter trajectories. Space agencies, ever vigilant, would manage this release with precision, ensuring that the integrity of their missions remains intact. And therein lies the beauty of spilling water in space. It's not just a whimsical thought, it's a gateway to scientific exploration, a chance to study the behavior of fluids in microgravity, to understand the nuances of condensation and evaporation in a realm where the rules are rewritten. Each droplet, each ice crystal becomes a lesson, a piece of the puzzle that is our universe. So as we ponder the implications of such an act, we realize that even the simplest of actions can ripple through the cosmos, reminding us of the delicate balance that sustains life on our blue planet.